ground wires, as well as the function of each.
Hello all. So in this video we'll be seeing about what are ground neutral and hot wires, ground fault, current and voltage, lightning strike and ground round, electrocution and GFCI. So every country has different names for it. And hot wire is nothing but the phase wire. So you know about neutral and ground. You will understand well in this video. He has explained very well about how this electricity flow will happen, how this neutral and ground. So I'm playing this video for you to understand well. So please watch this video.
With some worked examples. This video is for homes in North America. If you are outside this region, then you can still follow along, but your system will work and look a bit different, so do check out our other videos. Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. Before we get into this video, there are 3 things I need you to remember. Number 1, electricity will only flow in a complete circuit. If you come into contact with an electrical conductor, your body might complete the circuit. Number 2 is that electricity always tries to return to its source. And number 3, electricity will take all available paths to complete a circuit, but it will take preference to a path with less resistance, and so more current is going to flow in that path. Okay, so we're going to be looking at the hot, neutral, and ground wires for a typical North American residential electrical circuit. First, we'll see a really simple circuit to understand how it works, and we're going to apply this knowledge to a complex residential installation. When we look at a simple electrical circuit with just a battery and a lamp, we know that to turn the lamp on, we need to connect both ends of the wires to the terminals of the battery. Once we connect these wires, the circuit is now complete, and electrons can flow from the negative through the lamp and then back to the positive terminal. So for the circuit to be complete, we need a wire to carry the electrons from the power supply and over to the light. This wire is our hot wire. Then we need to connect another wire from the lamp and back to the battery for the electrons to get back to their power supply or from their source. And this wire is our neutral wire. The hot wire carries the electricity from the power supply and it will take this over to the load. The neutral wire carries the used electricity back to the power supply. If we look at a residential electrical system in North America, then we will find 2 hot wires, a neutral wire, and some ground wires. If you want to see in detail how this all works, then check out our video. It therefore flows through the hot, through the bus bar and the circuit breaker, and into the light. It then travels back through the neutral and over to its electrical source. Now, of course, homes are not connected to batteries, they are connected to transformers. So we're going to replace the battery with a transformer, and there we go, we have a complete circuit. The electricity in this circuit is AC alternating current, which is different from the DC direct current which we saw with the battery. With DC, the electrons flow directly from A to B in only one direction, much like the flow of water down a river. But in our homes, we have AC alternating current, which means the electrons alternate their direction between forwards and backwards, much like the tide of the sea. Now in North America, we have a split phase supply to most residential properties. So we have the 2 hot wires and 1 neutral wire. We simply have 2 120-volt coils which are connected together in the transformer. The neutral is then connected to the center between the 2 coils. When we connect our multimeter between the hot and the neutral, then we're going to get a reading of around 120 volts. And we get the same reading for the other one. That's because we're only using half of the coil in the transformer. But then when we connect between the 2 hots, we get 240 volts because we're using the full length of the transformer coil. If you don't have a multimeter, I highly encourage you to get one. Links down below for which one to get and from where. Now, if we have a load on only one half of the coil, and the load is, for example, 20 amps, then the hot wire will carry 20 amps to the load, and the neutral wire will carry 20 amps back to the source. We can measure the current in a cable using a current clamp meter. Again, links down below for which one to get and from where. If you don't know what current or amps are, then check out our video on electrical current, links for that in the video description below also. Now, if we have another load on our other half of the coil, and the load is a different value, say for example, just 15 amps, then the neutral will only carry the difference between these 2 values back to the transformer or back to the electrical source. So it is covered with a green insulation. This wire has a very, very low resistance, so electricity will prefer to travel along it because it's easier and can get back quicker. Is the metal casing, then it will run this from the positive terminal over to the lamp. We connect this to the metal of the lamp holder, and this is effectively our ground wire. As you can see, it's not being used to carry electricity. If the hot wire touches the metal casing, then the electricity will now flow through the ground wire instead. If the hot wire is connected to both the neutral and the ground, then it will now flow through both wires back to the source. But as the ground wire has less resistance, then more current will flow through it. When electricity finds a way to leave its circuit and return to the source through a different way than its neutral wire, this is called a ground fault. Coming back to the house, the electricity flows through the hot wire and into the light and then back through the neutral. But if the hot touches the metal casing, then it will instead flow through the ground wire, back to the panel, through the bus bar, and then back to the transformer via the neutral wire. The ground wire has a very low resistance, so it causes a huge and instantaneous increase in current, which will trip the breaker. We therefore connect the ground wires to anything that could potentially become a potential path for electricity to leave its circuit, such as the metal pipes, the metal plates and the light switches and the outlets of their boxes. We also need to run one to the outlets because often our appliances are made of metal or they're covered with a metal casing, things like washing machines and microwaves. When you look at a receptacle and plug, you'll see that there is a hot terminal, a neutral terminal, and a ground terminal. The casing of something like a washing machine is connected to a ground wire in the lead, which goes to the plug, through the receptacle, and back to the panel to save you from an electric shock. Now, let's say you're outside with no shoes on and the ground or the soil is moist. If you touch a hot wire, you could complete the circuit and the current may pass through you to get back to the supply. In this case, the resistance is going to be very high, so the current might not be high enough to automatically flip the breaker and cut the power. This will likely lead to the person's death. Luckily, we have the GFCI receptacle or the GFCI breaker. GFCI stands for Ground Fault Circuit Interrupter. We're going to look at a circuit breaker version, but essentially they're going to work the same. This GFCI breaker is going to be connected to both the hot and the neutral of the circuit, so we can monitor the wires and ensure that the current running in the hot wire of the circuit is equal to the current running in the neutral wire of the circuit. If the current is not equal in these two wires, then it's clearly flowing back to the source via another route. We then have a ground fault. The breaker will realize this and very quickly and automatically flip to cut the power and kill the circuit. Connected to the main panel, we will find a thick copper wire which leads out to a ground rod. The ground rod is buried into the ground outside near the property. This rod is not used for ground faults. Its purpose is to dissipate static electricity and external high voltages like lightning strikes. There is also a ground rod connected to the neutral at the transformer. Many people think that during a ground fault, electricity flows through their ground rod and into the earth. But remember, electricity tries to get back to its source. It doesn't just go into the earth. And as there is a ground rod at the transformer, then there is a potential path for the electricity to get back to the source. But this path will have a very high resistance or impedance. And as we know, electricity will take preference over the path with the least resistance. So as we already have a very low resistance ground wire, which provides a path directly back to the source, the ground fault is going to take this route instead. When it comes to lightning, the source of lightning is essentially the earth. So lightning is always trying to get back to its source, which is the earth. If lightning strikes the utility cables, it will flow along the wires to get to the ground rods of both the transformer and also your main panel. It's going to do this to try and get back into the earth. If it wasn't for this, then it's going to blow all our circuits and it's going to cause house fires. Now, if the hot wire came into direct contact with the ground rod, then electricity will flow through the soil back to the transformer, but the resistance is very high, so the current will be low. This means the circuit breaker will not likely detect the fault, and the circuit breaker will not automatically flip to cut the power.
So I hope this video has helped you a lot to understand what are the different types of wires, what is difference between ground and neutral and phase wire. That's he addressed it as hot wire. So this is very clear. I hope it is very clear. There's difference between neutral wire and ground wire. and you can consider this electric flow as a river flow, I mean sea flow. For example, from sea, when it evaporates, rain falls and rain comes, and it comes from the rivers, right? From the mountains and rivers, mountains ice melts, and somehow it comes back as a river. So you can see a river flow. A river flow is always stopped nowadays by either by constructing bridges, so you can consider those bridges as a transformers, and then power stations. From there, it is put through a pipeline. So you can consider this all electric poles, and this all which you see outside cities to and it is connected to our house lines. So that house line is nothing but a transformer. So from there, it is given to our pipeline to through taps. Okay. So from like this, you can consider it as main and other switches also, like how we have given for how kitchen connection, bathroom connections, and wash station connections in our house. So you can see the flow of current is always there. The flow of water is always there. When you use the water, you will store it. You will store it. So similarly, it is stored. The power is also stored until you on. Once you on it, the wastage will be going into the drain. So we have created another drain. And where will the drain ends? So from your house, it is going out. From where will that go? That will go again, and it is always outside the city. It is left again into a river, and from that river again it passes through where? It passes through a sea. Yes or no? So this how a river work goes on. So similarly, even for a power connection also, it acts the same. Okay, from houses it comes, and once it is done, it is have to go back. The flow is always should be there for an whether it's for a water or whether it's for an electric circuit. So to go on with this circuit, a ground connection is given, and we all say it goes to the earth. The earthing wire will goes into the earth, but you had the two. They will usually remove a pit, and pit with pebbles and dissolve will keep. And as he said, a transformer, a rod, and a rod is fixed where this will again return back to the transformer. This is how it is done. Okay, this whole process is the same. So you should be, this all will be useful for your Viva questions. So please remember them. And I'm ending this video. I hope this video has helped you to understand well. Thank you.